Today we're going to do a review on factoring. This is a concept that you learned in Algebra 1. It's a prerequisite to solving quadratics, which is where we're going next. Two different types of factoring we're going to talk about today. The first one is GCF factoring. GCF stands for greatest common factor. So this is the factoring where you are basically undoing your distributive property. First thing you want to do is identify your greatest common factor. Then you're going to divide all your terms by that common factor. And then your final answer, you're going to write it as a product of the GCF times the quotient. So whatever you end up getting when you do that division. Your final answer should look like something that you need to do the distributive property on. And that's how you check yourself. If you do your distributive property, you should get back what you started with. So here are a couple examples. I'm looking at this one, 20n squared plus 32n. You have to think about factors of 20, factors of 32. We want the biggest number that divides into both of those. And I know that 4 goes into both of those. So I just go over to the side and identify my GCF. So I know 4 goes into 20 and 4 goes into 32. And then you're going to look at your variables. If you have n to the second power, n to the first power, they have at least one n in common. So you're always going to use the smallest power that you see. So that's my GCF, 4n. So since our final answer, we're going to write it as the quotient, the product of our GCF times whatever our quotient is. Just set up a line on the bottom there to fill in your answers. So essentially what you're doing when you identify that GCF is you're dividing both terms by that common factor. And then you just put your answers right in there. If you start off with 2 terms, then you should have 2 terms in your parentheses. So if I divide 20 by 4, I get 5. If I divide n squared by n, I get n. And if I divide 32 by 4, I get 8. And then for this one here, my n's would just cancel right off. So it's 5n plus 8. That's your final answer. And if you want to check yourself, just do the distributive property. If you distribute 4n to 5n, you get 20n squared. And 4n times 8, that's going to give me positive 32n. And as you can see, that matches what we started with. Okay, so your answer is this factored form right here. Here's another one. If you want to pause the video and try it on your own real quick, you can. And then come back and check and see if you got it. First thing you want to do is identify your GCF. So a 21 and a 15, we have a 3 in common there. X squared and x, you're always going to use the smallest power. They have at least one x in common. So you're going to have 3x times a quantity. And if you need to, write that greatest common factor underneath each one of your terms, because that's what you're doing is you're dividing. And then the quotient's going to go inside the parentheses. 21 divided by 3 will give me 7. X squared divided by x will give me x to the first power. Bring down your minus sign. 15 divided by 3 is 5. And again, these x's are just going to cancel each other out. Okay, the next type of factoring we're going to review is your trinomial factoring. We have 2 different kinds. We have the easy one and we have the hard one. The easy one is the one where you have your a equal to 1. So the number out in front of your x squared or your quadratic term is just a positive 1. So for this, you're going to find factors of c. So that's going to be my constant that add to b. And b is going to be the coefficient of x to the first power. So if you remember our standard form of our quadratic, ax squared plus bx plus c. That's what I'm referring to when I talk about a, b, and c. So we need factors of c that add up to b. And this is only when a equals 1. And then you're going to write your final answer as a product of two binomials. So two binomials, so whatever those numbers end up being, it'll be like x plus a number, I'll just make it an m, and x plus another number. It could be a plus, it could be a minus, but it's going to be a product of two binomials. So whatever numbers you find that are factors of c and add to b, they're going to go right here. So let's try one. X squared minus 5x minus 14. I see that my a equals 1, my coefficient out in front of my x squared. So right here, this is a positive 1. So all I need to do is find two numbers that when I multiply them, I get negative 14, but when I add them, I get negative 5. Those leading terms are both going to be x. Once you find the numbers, negative 7, positive 2, because negative 7 times positive 2 will give me negative 14, but negative 7 plus 2 will give me negative 5. So it's as easy as that. Factors of negative 14 that add to negative 5. That's how we found those numbers. Factors of negative 14 that add to negative 5. So if you're really good at your multiplication, these aren't going to be too bad for you. Okay, so this one, x squared minus 16x plus 63. So I need two numbers that when I multiply them, I get a positive 63, but when I add them, I get a negative 16. Now, because this is a positive here, and this is a negative, I know that when I multiply them, they have to have the same sign because it multiplies to a positive. So I know both my signs are going to be negative. Because if they multiply to a positive, the signs are the same. But if they add to a negative, they have to both be negative. So now we just need the two numbers. So 63, I know, is divisible by 9. So 9 times 7 will give me 63, positive 63. And when you add those together, you get negative 16. So those are your numbers. So again, we're looking at factors of c. For this one, it was factors of 63 that add to negative 16. Okay, I'm going to pause the video and try this one on your own. Okay, so I need two numbers. I know this is going to be an x, this is going to be an x. Now this is negative here, so my signs are going to have opposite, or sorry, my numbers are going to have opposite signs. And since this is positive, the bigger one is going to be positive. So what am I looking for? I'm looking for factors of negative 27 that add to 6. So I know that 27 is 9 times 3. Since they multiply to a negative, one of those numbers has to be negative. But since they add to a positive, we're going to make the bigger one positive. So positive 9, negative 3. 9 minus 3 is 6. So those are my numbers. And that's your answer. This is the factored form. Okay, and then trinomial factoring when a does not equal 1. These ones are a little bit more difficult because you have some added steps there. So instead of just looking for factors of c, the first thing we have to do is we have to multiply a times c. And then we want to find factors of that number that add to b. And then we're going to split out our middle term, and we're going to factor by grouping. So what we're doing is we are unfoiling, basically. So here's an example. The first thing you want to do is multiply A times C. A times C. My A is 7. My C is -8. So that's going to give me -56. Okay, so now I need factors of -56 that add up to -55. Those two numbers are -56 and +1. Because when you multiply those, you get -56, but when you add them, you get -55. Okay, and then what you're going to do is you're going to split your middle term. So you're going to rewrite this trinomial, where you're going to take this middle term, instead of writing it as -55a, we're going to split it out into these two numbers that we just found. So you keep the first term, your 7a squared, and instead of the -55a, you're going to write -56a plus 1a, or just a, and then you copy down your -8. Okay, and now we're going to do our factor by grouping. So recall that factor by grouping is whenever you have 4 terms, you don't have anything in common with all 4, but if you group it, then you will be able to pull out a common factor. So if I group the first 2 here and group the last 2, I'm just going to look for GCFs of those. So for a 7a squared and a 56a, I know that I have a 7a in common. So you're going to be dividing both of those terms by 7a. If you need to write it, then go ahead. Okay, 7a squared divided by 7a gives me an a. -56 divided by 7 is -8. And then my a's are going to cancel off. Now when I go to the second pair here, they don't have anything in common, so I'm just going to use a 1. You're always going to take this sign and make it match right here. So if there's nothing in common, we're going to use a 1. You either use a +1 or a -1 based off of this sign right here. So I'm going to use a +1. And dividing stuff by +1 doesn't change anything. So this is going to be a -8. Okay, and then you should have these two quantities right here. If you picked the right numbers and you did everything right, then those two quantities are going to match. So that is my common quantity. It's kind of like the common factor of those two chunks that I have here. So the common quantity is a -8. And then the stuff around it that's left over, if you think about canceling off that a -8, you would be left with 7a plus 1. Okay, and again, your answer is going to be a product of two binomials. And if you want to check yourself, all you do is you take that and you FOIL it. And if you FOIL that, you should get what you started with. Okay, let's try another one. All right, 3k squared minus 38k plus 80. So the first thing I have to do is I have to multiply a times c. So that's 3 times 80. And that's going to give me a 240. So I need factors of 240 that add up to -38. Just check. So it's a positive 240, it's a -38, so both my signs are going to be negative. We're going to use -8 and -30. Sometimes the hardest part is finding these two numbers. Okay, so once you have those two numbers, I know I'm going to rewrite my trinomial, but instead of writing my 38k, I'm going to split out that middle term. So you copy the 3k squared, you split your middle term. So we're going to write it as negative 30k. It doesn't matter what order you put it in. You get the same answer. Minus 8k, and then plus 80. So you just split out that middle term. So now we're going to do our factor by grouping. So you're going to group it 2 by 2. Take these two together, take these two together. So a GCF from the first two, 3 and 30, gives me a common factor of a 3. K squared and K gives me a common factor of a K. So write down your GCF, open a parenthesis, and then you're dividing both terms by 3k. If I divide 3k squared by 3k, I'm left with just k. If I divide negative 30 by 3k, negative 30 divided by 3 is negative 10, and my k's will cancel each other out. Then you go to your second set. So if I'm looking at, you're going to look at the sign here too, negative 8k and 80. You always want to use the sign that's right here. I see there's an 8 in common. Since this is a negative sign, I'm going to use a negative 8. And then open a set of parentheses. So you put a negative 8 under each one of these. We can't take a k out because only one of them has a k. And then we divide. Negative 8k divided by negative 8 just leaves me with a positive k. And 80 divided by negative 8 leaves me with a negative 10. And this is good because look at this. These guys match. And that's what you want to happen. If you pick the right numbers when you're doing this step over here, then these will match. Okay, so my final answer then is going to be my common quantity of my k minus 10, and then the stuff left around it, my 3k minus 8, that becomes the other quantity. And that's your answer. Again, you just FOIL to check. All right, I have one more example, so go ahead and pause the video and try this on your own, and then come back and see if you got it. All right, so I need to multiply a times c because my a, number in front of my quadratic term, is not equal to 1. So a times c, which means I need 5 times negative 6. That's going to give me negative 30. So now I need factors of negative 30 that add up to 1. So let's go with 6 and negative 5. Because 6 times negative 5 will give me negative 30, but when I add them, positive 6 and negative 5 gives me a positive 1, which is what I need right here because this is a positive 1. Okay, now we're ready to split our middle term. So you copy down the 5r squared. You split that middle term. I'm going to put the 5 first because I feel like it goes with this first term better. Negative 5r plus 6r, and then your minus 6. And then we're going to do our factor by grouping. I see that I have a 5r in common here. So I'm going to take out a 5r, open my parentheses. So you're dividing both of these by 5r. 5r squared divided by 5r is just r. And negative 5r divided by 5r is just negative 1. And then when I look at my second pair, I see that this is a positive sign, so it's going to be plus. 6 is in common. And then I open my parentheses. So I'm dividing both of these by 6. 6r divided by 6 is just r. And negative 6 divided by 6 is negative 1. And good, it matches. So r minus 1, r minus 1 is our common quantity. And then the stuff around it, 5r plus 6, if you imagine like canceling these off, what would be left? The 5r and the plus 6. So that's my other quantity. And there's your final factorization. And again, FOIL to check. Okay, so I'm attaching a practice sheet for you guys for this. Like I said, this is a prerequisite skill for our next section, which we'll do on Monday. Your answers are on the back. I gave you a lot of problems. You don't have to do them all. If you remember factoring from Algebra 1 and you want to do a few problems and you feel confident you'll be okay in the lesson on Monday, then that's fine. But if it's something that you need practice on, please practice, because starting on Monday, I'll just assume that you know how to do this. And of course, you can always email me if you have questions or if you need to see more examples. All right, have a good day and have a great weekend.